Hello, I'll now be presenting my FYP project on detection of crop fields in Ukraine using the S1 MSI Vegetative Index developed by Yara International. Yara is a fertilizer company that provides many capabilities and solutions to farmers. One of those solutions is the CropWise solution, which is only used by farmers in Ukraine for the time being. Farmers using Yara solutions use the FarmCare app to draw their field boundary by walking on the parameters of the field or just by drawing it on the Google satellite map provided in the app itself. The area of these fields are then added up and reported as active hectares under management. Yara uses this active hectares under management metric to quantify the performance of the CropWise solution. However, nothing prevents a farmer from testing out the field boundary drawing feature by drawing a boundary of anything other than his crop field, such as his house. Therefore, it's crucial to be able to discriminate field boundaries that are actual crop fields from ones that were drawn by mistake. So essentially, the goal is to build a supervised learning model that takes in the field boundaries and classifies the field as either a cropland or a non-cropland. So the first step for that is to get the ground truth data. The ground truth data for this project is the shapefiles of farmlands in Ukraine, which was obtained from OpenStreetMap. OpenStreetMap is an initiative to create and provide free geographic data such as street maps for anyone to share and use. All Ukraine shapefiles were first downloaded. The shapefiles are split into different categories such as land use, places, water bodies, and more. For the interest of this thesis and to simplify things, only land use shapefiles were used. The land use shapefile consists of 20 tags of land type, farmland, and the other 90. Only the tag land use equals to farmland refers to croplands. Hence, if the CropWise field lies within a farmland polygon, then it is a cropland. The pink polygons in this image represent farmland polygons. The yellow outlines are outlines of the CropWise field boundaries. It can be observed that all the CropWise fields in this figure correspond to a cropland. An example of a non-cropland is shown in this image where a CropWise field is in a green polygon. The green polygon represents a land type other than farmland. Using the Select Feature tool in QGIS, it was confirmed that this field boundary belongs to a residential area and not a cropland. After getting the ground truth data, I realized my dataset was unbalanced. Since there were significantly more cropland fields than non-cropland fields, fields belonging to the non-cropland classes had to be included to create a balanced dataset for training. However, since there are 19 other classes, dimensionality reduction had to be applied, and this was done through the domain knowledge and geospatial analysis. Only fields belonging to the industrial areas, forest, heath, quarry, and residential areas were chosen to be included into the dataset. These 5 classes were specifically selected as they represent a wide range of possibilities of non-cropland areas. Instead of plainly using a one-time S1 MSI value, as used in some of the past studies in the topic, capturing the temporal shift of the index was deemed to be a better approach. The logic behind this feature is that if a crop is being grown in a particular field, the S1 MSI values will change in a periodical manner over the years, owing to the different growth stages from seeding until harvesting. This image depicts how the S1 MSI value for a crop would change over its growth stages using wheat as an example. The S1 MSI data for the past 5 years from Jan 2018 to Jan 2023 was collected for every field and was plotted in a S1 MSI against time graph. From the plot of the S1 MSI of a field, the first and last peaks of the graph were identified. The data was then cropped from the first until the last peak. The FFT algorithm was then applied to convert it from a time domain to a frequency domain graph. Out of the 3 peaks identified, since the highest frequency peak corresponds to a period of 390 days, that is deemed to be the main seasonal component of this graph. Features such as maximum and minimum as S1 MSI, presence of seasonality, periodicity, and finally the size of the field were extracted. Random forest is the best performing classification algorithm for this task with a high accuracy value of 93%. The most important feature for all 3 classifiers is the maximum S1 MSI value, which can be explained by the purpose of S1 MSI. Since S1 MSI is proportional to the chlorophyll content detected in a field, the higher the maximum S1 MSI value, the more likely it is a field with plants and less likely buildings. From the feature importance graph of random forest, it can be observed that the maximum S1 MSI value is the most important feature, followed by the periodicity and presence of seasonality with negligible difference between them. From the box plot of the maximum S1 MSI values plotted for the different classes, it can be noted that heath, industrial, and quarry can be easily told apart from cropland, as their maximum S1 MSI values are significantly lower than that of cropland. It is also apparent that croplands have the highest median score of around 43. A meaningful FFT graph is only produced if the peaks of the graph are identified and if the cropped graph is periodic. Since the threshold value to identify peaks was set to 25, peaks are not identified for quarry and industrial, giving no FFT graphs. The same goes for heath in the next slide. Even though peaks are identified for residential area, they're too close to each other, so seasonality is not identified. Time series graphs of forest fields are the most similar to cropland fields as they tend to have a high S1 MSI value, as well as seasonality. This might be due to the seasonal changes in Ukraine where the leaves have high chlorophyll content in the summer and spring, and low chlorophyll levels in autumn and winter as they wilt and fall. In conclusion, a classification approach using Yara's very own S1 MSI temporal data, which categorizes a piece of land to either cropland or non-cropland, was proposed to detect crop fields accurately. A dataset containing fields from 5 land use classes: forest, residential, industrial, quarry, heath, apart from cropland was constructed and used for cropland features extraction, classification, and accuracy testing. The result of this cropland classification project is very satisfactory as the categorization outcomes are quite accurate. And with that, I've come to the end of my presentation. Thank you.